So in this part of the lesson, we're going to continue going through some examples in which we have a combination of transformations. So this question reads, find the equation of the image of y equals the square root of x after a dilation of a factor of 2 from the y-axis, followed by a translation of 2 units in the negative direction of the x-axis and 3 units in the negative direction of the y-axis. Okay, so as I said before, there are 2 ways of thinking about these questions. You can do it kind of the quick way, which I call by inspection, and then the longer procedural method, which we call just by the method. So just doing it by the method. So in terms of doing it by inspection, what makes these ones more difficult to do by inspection is the fact that we have a dilation from the y-axis. So the fact that we have a dilation from the y-axis makes it a little bit more tricky when doing it by inspection. So just for this example, I'm going to begin by doing it by the method, and then we'll circle back and do it by inspection. So let's just begin by doing it by the method, just to kind of get our head around it. And remember, by the method is always a legitimate way of doing it. It's quick, it's effective, and importantly, you're less likely to make a mistake when doing it by the method. Okay, so we start off by writing this, then this, and this. Then we rewrite it, and we ask ourselves the question, what is x dash going to be? Well, because I have a dilation of a factor of 2 from the y-axis, that means it's going to be 2x. And I also have 2 units in the negative direction of the x-axis, so it's going to be minus 2. And then in terms of my y dash, the only thing happening to it is 3 units in the negative direction of the y-axis. So I have a translation, which is going to move it 3 down. The next thing that I do here is I say x dash, so actually, let me do it the other way around. 2x minus 2 is equal to x dash, and then y minus 3 is equal to y dash. Now we're going to rearrange these for x and y. So that means I'm going to end up with 2x equals x dash plus 2. X is going to be equal to x dash plus 2 over 2. And then on this side, I'm going to end up with y is equal to y dash plus 3. So these 2 equations I have just created are very important because they're going to be what I substitute into my original equation I was given. So the original graph I was given was y is equal to the square root of x. Into the y position, I'm going to put this, y dash plus 3. And into the x position, I'm going to put this right here. So let's make this big. It's going to be x dash plus 2 over 2. Now remember, I'm going to drop the dashes and solve for y. It's going to be y is equal to the square root of x plus 2 over 2 minus 3. That right there is going to be my answer. So let's highlight it. Okay, let's now talk about how we would do this by inspection, and specifically why the fact that it's dilated from the y-axis makes it just a little bit more tricky. So if we were doing it by inspection, you would begin by saying, all right, I have this as my original. If I'm dilating it by a factor of 2 from the y-axis, that means into the x spot right here, I substitute in the reciprocal factor, so the reciprocal of the factor that I'm dilating by, so it's going to be a half x. Then, if I'm translating 2 units in the negative direction of the x-axis, this is where people make the mistake, into the x position right here, so let me just make this a bit bigger. Into the x position, I'm going to sub in x plus 2. And then I have 3 units in the negative direction of the y-axis, which is going to be minus 3. Let me just fix up this square root because it's kind of ugly. Let me try one more time. Let's make a pretty square root. There it is. That would be our answer. And this is the same as that right there. I've just got a half here instead of this divided by 2 there. But it's the same. Now, the reason why people get so freaked out by these type of questions is if I was to expand what's in the brackets here, what I would end up with is y is, actually, let me just do this. I would end up with the square root of a half x plus 1, because a half times 2 is 1, and then minus 3. Now, when you're looking at this, would you tell me that I am translating it by 2 units? Well, not initially, because you'd see this one and it would kind of confuse you. So the fact that people get confused with that is the reason why when it comes to doing dilations from the y-axis with a combination of other transformations, it's normally recommended that you just do by the method, and that way you're less likely to make a mistake. I will be showing you in later lessons, as long as you factorize and you're careful, you can do it by inspection, but it's just a little tricky. So, all right, this is correct, and this too is a correct. All right, let's keep on going, and we're going to do another one of these. Actually, before I go on, let me just show you what this would look like if I was to graph it. All right. So we're doing this one. All right, so I've got this square root right here, and let me just bring this up a bit more. I've got this square root right here, and the first thing that I'm going to do is a dilation of a factor of 2 from the y-axis. So that means I'm going to do this. I'm replacing my x with a half x. So remember, it has to be a reciprocal. And as you can see, I'm now further away from the y-axis because I'm dilating by a factor of 2 from the y-axis, and I'm now further away from it. The next thing that I'm going to do is a translation of 2 units in the negative direction of the x-axis. So that means I'm going to replace my x with x plus 2. Whoa, what happened there? I've got too many x's. There we go. So as you can see, I have now moved it 2 units in the negative direction of the x-axis, and you can see the importance of brackets there. And then the final thing I had to do is 3 units in the negative direction of the y-axis. This is always the easiest one. We're just going to subtract 3 to the outside, and it moves down. So hopefully you can see the importance of really paying attention when you have dilations from the y-axis, because not only do you have to deal with that reciprocal, but also when you have translations in the x-axis, you really have to be careful about how you're writing it. Okay. Let's now bring this up and go on to the next question. Here it is right here. Oh, come on. There we go. Okay, so again, we can do this by inspection, but we've just got to be really careful. But let's give it a go. So we're starting with y is equal to 1 over x. And we're told that it is dilated by a factor of 2/3 from the y-axis. So that means into my x spot, I'm going to substitute in the reciprocal of this factor. So I'm just going to swap the numerator and the denominator, which is going to be 3 2x. Then it's followed by a reflection in the x-axis. Remember, when we're reflecting in the x-axis, we just give the whole thing a negative. We just put a negative in front of the whole thing. Next, we have a translation of 3 units in the negative direction of the x-axis. This is where we have to be careful now. Let me just do this like that. What I'm going to do is I'm going to replace my x with x plus 3. And then finally, I have 1 unit in the negative direction of the y-axis. So that's just minus 1. So that right there is going to be my answer. The only thing that I would want to resolve here is I don't like how I've written that. The better way to write this would be like this. I can just bring this 2 to the top. Minus 1. Okay, so that is going to be my answer. Let's go through the long procedural way to answer this, and I'll show you what's going on. By the method. Okay. Actually, I need to look at this. So it's going to be x, y, then x dash, y dash. Then I rewrite it. And now I'm going to ask myself some important questions. What is my x dash going to be? Well, because I am dilating by a factor of 2/3 from the y-axis, I'm going to go 2/3 x. And I have a reflection in the x-axis. That's not going to affect this. Translation of 3 units in the negative x direction. So that's a minus 3 here. And now I can look at what my y dash is going to be. Because I have a reflection in the x-axis, that means it's going to be negative y. And I also have 1 unit in the negative y direction, so it's going to be minus 1 there. All right, now that we've gotten that, we're now going to create our equation. So this is equal to this. So it's going to be 2 that minus 3 is equal to x dash. And then negative y minus 1 is equal to y dash. Now I'm going to solve for x and y. So I'm going to end up with, now do these slowly, no rush. I'm going to end up with x dash plus 3. And now here, what I'm going to do, feel free to do this slowly. I need to get rid of this 3, so let's multiply both sides by 3. And by doing so, those 3's are going to go away. And what I'm going to be left with is 2x is equal to 3x dash plus 3. And now I need to get rid of that 2, so I'm going to divide by 2. So I'm going to be left with x is equal to 3 on 2 x dash plus 3. As you can see, here I had 2 over 3x, and then when I brought it over, it's just the reciprocal of it, so you can kind of use that as a shortcut. That is one thing that I need. Let's now figure out what y is going to be. This is going to be quite easier, and remember, do it step by step so you don't make any mistakes. I'm just going to bring this plus 1 over, and then I'm going to divide both sides by -1. So I'm going to divide this by -1. I'm going to divide this by -1, and what I'm going to be left with is y is equal to negative y dash minus 1. Okay, now that I have those, let's just zoom out here. I remind myself what the original graph was, and I've already forgotten. What was it? It was 1 over x. It was y is equal to 1 over x. Into the y position, I put this. Negative y dash minus 1 is equal to 1 over. In the x position, I put this right here. So it's going to be 3 over 2 x dash plus 3. Then I solve for y and drop my dashes. So it's going to be negative y is equal to 1 over 3 on 2 x dash plus 3 plus 1. And now I'm going to divide both sides by -1. So just to make sure that we're all on the same page here, I'm dividing this by -1, and I'm dividing this whole thing by -1 there. So that means what I'm going to be left with is y is equal to -1 over 3 on 2, whoops, x dash, actually I'm getting rid of the dashes. Getting rid of the dashes, x plus 3 minus 1. And as I said before, this isn't the prettiest way to write it with a fraction here. What we much prefer to write is just put this 2 up the top, this 3 stays there, x plus 3 minus 1. Oops, and that should be a minus, because there's a minus there. And that, right there, is the answer. And that's what we should have gotten up here, and did we? -2, 3, x plus 1, yes, x plus 3, minus 1. I've just put the negative there, but the negative up there is the same thing. Okay, so you can see it is a little complicated, but we got the same result. You just have to be very careful when you're going through these, and just be careful with what's happening. But hopefully you found that intuitive. In the next part, I'll go through some more examples. All right, hopefully you found this useful. Bye-bye.